Okay, today we're going to learn about the logarithmic differentiation. Now, before we do this, I'm going to review a couple of things we've already learned about finding derivatives. Two functions important, like the power rule. So we call the power rule is when y is equal to x to the n, and when we differentiate that, we use our power rule. We reduce the power to the front and then decrease the power by 1. So we get derivative of y with respect to x is equal to n times x to the n minus 1. Now, notice that this derivative, that the base is a variable. So if only the base is a variable, you will find the derivative by using the power rule. If the base is a variable and the exponent is a number. Okay, and then the other one, we learned the exponential rule recently, where if we have y equals a to the x, where we have a number raised to the x power, our derivative is a to the x times the natural log of a. In this case, we use the exponential rule when our base is a number, but our exponent is the variable. So here, we will use the exponential rule. So if only the exponent is a variable, we will use the exponential rule. Today we're going to learn what would we do if the base is a variable and the exponent is a variable. So if we have the function y is equal to f of x raised to g of x. So both of these are functions of x. Now our only caveat is that f of x has to be greater than or equal to 0. Again, we use logarithmic differentiation when the base has a variable and the exponent has a variable. And the reason why f of x needs to be greater than or equal to 0 is we're going to put that inside of natural logarithms. And remember from previous courses, you learned that the number inside the natural log has to be greater than or equal to 0. So the process of doing logarithmic differentiation is the following 3 steps. The first step is that you're going to take the natural logarithm of each side. Once you do that, then you're going to differentiate both sides of the equation, not just the one side of the equation. We're going to take the derivative of both sides of the equation with respect to the x variable or whichever variable is your independent variable. This is going to be crucial that you recognize that we're taking respect to the x variable. And then what you're going to do is that resulting equation, you're going to solve for your dy dx, your derivative of y with respect to the x variable. So let's see how this works in action. So let's find the derivative of the function y equals x to the x power. Okay, we're going to use a logarithmic differentiation here because our base and our exponent are both variables. So step 1, we're going to hit each with the natural log. So I'm going to take the natural log of the y, and I'm times it by the natural log of x to the x. So let's look at the right-hand side of this. Now remember from previous classes that when you have an exponent inside a logarithm, you can bring it to the front and multiply it by the logarithm. You will do that step. Then I'm going to take the derivative of each side. Well, we know the derivative in the natural log of y is 1 over y, but y is not our variable. Our variable is x. So y is a function of x. We have to multiply this by the derivative of y with respect to x, which is that whatever that function is. And then to take the derivative of the right-hand side, we're going to need to use what's called the product rule because we have two functions multiplied together. So I'm going to take the derivative of the first times the derivative of the second plus the second function times by the derivative of the first. All right, let's simplify this a little bit. And on the right-hand side, we end up with 1 plus the natural log of x. Okay, next, we want to get dy dx by itself. So we know we're multiplying by 1 over y or dividing by y. So to get the dy dx by itself, we're going to multiply each side by y. And so I get that dy dx is equal to y times 1 plus the natural log of x. Y was defined to be x to the x power. That's what y equals. That was given in the problem. So what we need to do is we need to go back to the original variable of x. We're going to place this y with x to the x power. And so our answer is the derivative of y with respect to x is equal to x to the x power times 1 plus natural log of x. So to recap, to find the derivative when you have a variable in the base and a variable in exponent, you hit it with a log, differentiate both sides, solve for dy dx. Now I want you to try this one. Notice our independent variable this time is w. So we have a w in the base and a w in the exponent. So since both of them are variable, we're going to do the logarithmic differentiation to solve this problem. So what you're going to do is you're going to hit both sides with the logarithm, the natural logarithm. And then you're going to move the exponent to the front. So I'm going to have the natural log of y is equal to 2 over w times the natural log of w. Now, to make this a little bit easier so I don't have to do the quotient rule, I'm going to rewrite 2 over w as 2 times w to the negative 1. And so now we're going to take the derivative of the left-hand side. So derivative of natural log of y is 1 over y. And then we times that by the derivative of y with respect to x. Because remember, y is a function of x. And then we're going to let this equal to, or function of w. Sorry, I said x. Because our independent variable is w this time. Okay, we're going to have that equal to our derivative of the right-hand side. Now to do this derivative of the right-hand side, I'm going to need to do the product rule. Okay, so that is the first function, copy down, times by the derivative of the second function, which is 1 over w, plus our second function, copy down, times by the derivative of the first function, which is the power rule. So it's going to give us negative 2w to the negative 2. Let's clean up that right-hand side. Okay, so what do we need to do next is we're going to multiply that together and get 2 times w squared minus, let's bring that exponent down. So that's going to be 2 times the natural log w over w squared. So we can add those fractions together because they have, or subtract those fractions, they have a common denominator to get 2 minus 2, the natural log of w over w squared. And then again, we need to get the dy dx by itself. So I'm going to multiply each side by y. So I'll end up with dy dw is equal to y times the fraction 2 minus 2 natural log of w over w squared. Now recall from the given equation, it was defined that y was equal to w to the 2 divided by w power. So I'm going to replace that y with w raised to the 2 over 2 divided by w. And I'm going to times it by 2 minus 2 natural log of w over w squared. And that's simplified enough. And that would be our answer to this differential problem. Okay, I'm going to do one more example. And the reason why I want to show this is we can have any type of variable in the base in the bottom. As long as there's any variable in the base and any variable in the exponent, we're going to use logarithmic differentiation. So what the first thing I need to do to work this problem is I need to take the natural log of each side. So I'll have the natural log of y is equal to the natural log of the cosine of x times by raised to the sine of x power. Now remember, first thing I'm going to do is to solve these logarithmic equations, I'm going to bring that exponent to the front. And that becomes the sine of x times by the natural log of the cosine of x. So differentiation both sides, we get the derivative of the left-hand side is 1 over y dy dx. And to find the derivative of the right-hand side, we're going to have to use the product rule. So the first term times by the derivative second term, derivative of this, in order to find the derivative of natural log of cosine of x, we have an inside function, so that means we're going to have to use the chain rule to find this derivative. So the derivative of the natural log is 1 over, in this case, cosine of x. And then we times out the derivative of cosine of x, which we now know is negative sine of x. And then we're going to add the second function, which is the natural log of cosine of x, and we're going to times it by the derivative of the first function, which is cosine of x. All right, let's clean up that right-hand side. Multiplying this first term together, we end up with negative sine squared x over cosine x plus cosine x times the natural log of the cosine of x. Notice I cannot combine that cosine inside the logarithm with the cosine outside the logarithm. They're separate terms. All right, this could be easily to add these two fractions together by finding a common denominator. So I'm going to multiply that last fraction by cosine of x over cosine of x. And so I end up with negative sine squared of x plus cosine squared x times the natural log of the cosine of x. And that's all over the common denominator of cosine of x. We need to multiply each side by y, so I can get dy dx by itself. Don't forget that we have to replace y with a variable in terms of x, so we go back to the given problem. Y was defined to be cosine of x raised to sine of x. So we're going to replace the y with cosine of x to the sine of x power. And that's times by this fraction, negative sine squared x plus cosine squared x times the natural log of cosine of x over cosine of x. Now notice some people might think, well, we see sine squared plus cosine squared. That's 1, right, from Pythagorean theorem? No, because that cosine squared is being multiplied by that natural log, so you can't do anything with that. So that is our simplified answer.